Hey folks, welcome back to another episode of Foss. This time we have here with us DB. Yeah, he's a security researcher at BHIS and he's previously worked with companies like Meta, Amazon, and GPMC. Today he'll be talking about how to secure your open source applications. The stage is all yours, Steve.
So just give me a second for presenting this.
Sure, sure.
Here we are. So just a quick confirmation. Everybody can see the screen. Oh, there it is. I am guessing you guys can see this. All right. So hi guys. Debjeet. Some of you might know me from my previous conferences, and thanks to Foss Club for inviting me over for another talk. So I'll just begin with quick introduction. So basically, I am a security researcher with this very cool place called BHIS, called Black Hills Information Security. Those of you who are in security already might know about them. Those of you are who aren't into security just know that it's. I've worked at a lot of places, and these people are my favorite. Before this, I was a consultant with this company called Certus, where we used to do consultancy business. And even before that, I was again a researcher with this company called IIIT, which is one of India's biggest security companies. Apart from that, talking about Foss contributions, since this is a talk about Foss, security folks will know about Metasploit. Then there is PyTorch Lightning, Nutica, which is a Python compiler. Yup, a Python compiler. And OWASP, it's a security organization. They have a bunch of repositories out there related to security stuff. And that's most where most of my work is. So coming back to other things outside of work, when I'm not in front of a screen, or rather when I'm not in front of a VS Code or coding, I like to play Souls games. I pet every cat I see. I have a bunch of scratch marks from them, but they usually let me do that. I like the music of J. Cole and TV Girl. And if anybody wants to talk about Russian literature or tattoo ideas, just catch me up outside this call. And things I hate, top out there is C++ and JavaScript. I absolutely hate them. I get a lot of debates about this. We do not need more JavaScript frameworks or C++ magic. Just use C or Rust. It's better. And also, I hate people talking about open source and DSA gurus on Twitter. You know the kind out there. So, anyways, coming to the main agenda of the talk. So, security and Foss. So, as a security researcher or as a quote unquote hacker, a lot of questions which I've been asked throughout my career is that, hey, how can I, as a security researcher, contribute to open source, right? Because open source is a big game, and security researchers, they are not always more aligned with coding because we are mostly penetration testing. We are good at code reviews, but not writing code at times. So in a scenario like that, how do you contribute to open source, or how do you have those little green tiles on your GitHub, right? So I'll break this talk down into three parts. Like, why should you care about open source security? Like, okay, I there is a bunch of repositories out there. Why do I need to worry about security on them? Um, the second thing is, you can make money out of it. Now, when we talk about open source contributions, we usually think from a, let's say, uh, career perspective, that hey, this will look good on my resume, or this is something I actually believe in. But there are places in secure open source where if you make security related contributions, you can make anywhere from $20 to $20,000 right there. So that's pretty interesting. And third part where I would like to talk about is some hacks and cheats, which essentially trivialize a lot of the things which happen out there. So these are the three parts, and at any point, just feel free to ask me questions and things like that. So yeah, moving on. Why should you really care about for security? So I'll break this argument down in two parts. One is for hackers, one is for developers, right? And people like me who are somewhere in between and are extremely, extremely bored, right? So Open source libraries run the world. It's none of it is new, but they aren't the most secure ones. A couple of examples off the top of my head where security played an important part is, if you have been active in the tech space quite recently, there was a big bubble. There was a big noise on the tech space because somebody had backdoored one of the open source libraries, and it was only caught because someone working in Google or Microsoft, I don't know exactly where the guy worked, he noticed a 500 nanosecond delay in his SSH logins. And upon auditing the code, he noticed that, hey, there is a backdoor in this thing, which would give anyone access to my server, which is not okay at all. Right. And that code is open source. That code is open source. But everybody just took that out and was like, you know what, I'm going to trust this. And that lay there for a long, long time. Even with something like Baron Samedit, which was a big vulnerability in the pseudo binary, right? Which was a big talk back in 2022, if I'm not wrong. So that code was also open source, but there were those vulnerabilities which got entire developers all across the world sitting on a Friday in front of the laptop and pushing out updates to fix that. So that's one. So all your think about the last project you did. What was the first line you wrote? Probably import something from somewhere, right? That particular line that probably uses open source repositories, and those repositories itself might have vulnerabilities which affect your code, which might carry forward to your code. This is for developers. Now coming to hackers, like as a hacker, there's something called bug bounty, where you find bugs and you get a bounty of it. You get money, you make money of the whole thing, right? So bug bounty is extremely difficult. I find bug bounty extremely difficult. I was never able to get my foot into it. But when it comes to open source, it gets a bit easier, I would say, because you have access to the code base. You can see how this particular request has been processed or what are the mitigations in this place. And in a scenario like that, you can go through a lot of trial and error and figure out what works. Right. Another thing which you do as a security consultant is called secure code review. You take a piece of code someone wrote and you get to complain about it. That, hey, this piece of code is not secure. And some of it is extremely silly, some of it is extremely funny, and some of it is extremely clever. Right. So if you have an open source code base of a big project, let's say you have a machine learning library or a web UI interface or an electron application, so you can get really, really good at this because you have a cheat, you have the source code of the thing, and you can practice with that. Hey, I think this might be something. This might be a attack vector. You can just look it up, see what's happening, put some debug statements there. Nobody's stopping you. And third is software maintenance. Now, I've seen a lot of, let's hear a term called CVE, which is a critical vulnerability. I forgot what the E stands for. But CVE is essentially a number associated with a vulnerability, which helps you track software. Like, hey, this software has this CVs, right? These are the three vulnerabilities in there. Now, a lot of developers are reluctant about CVs that, hey, I don't want to show that my repository has vulnerable code. But the point is, having CVEs and things like that is a good thing. It shows that you know how to properly maintain a code. Open source, I've seen a lot of people thinking that open source is just about writing good code. And as somebody who has been working in the industry, let me tell you something. You don't need to be an amazing coder to write amazing software. I'll give you one example. Has anybody in like, feel free to answer this in chat, has anybody heard of this game called Undertale? It's a massive indie game. It's a massive indie game. And it has the shittiest code base ever. It's a bunch of if else statements. It's extremely bad code base, but it gets the job done. It is one of the biggest indie games as we speak, right? So good software, writing good software isn't just about writing good code. It's also about maintaining that code, auditing that code. That, hey, these are the vulnerabilities in this version. We'll fix that in the next version. And you won't always write secure code in the first go. So for these three reasons, I think it's extremely important to audit your code or audit someone else's code and keep that thing going. So how do you go? What is the right way to do this? Like, hey, how do I go about the discipline of adding, let's say, the right audits in place or the right procedures in place? So there are two resources out there which I'll really recommend everyone reading. If you have a website, if you have a website which promotes open source or is related to, or in fact, any website in general, GitHub has this thing called security.txt. Go through this. It essentially states that what this file does is very similar to robots.txt, but it specifies the security principles which you follow. And another thing is, what is security.md? Big repositories, big code bases, they have something called security.md, which describes how, if you find a vulnerability in this particular code base, how do you go about disclosing it in a manner. You don't want to create a GitHub issue saying that, hey, you can, let's say there's a web app and you find a security vulnerability. You don't want to create an issue. So, if they don't have a security.m, that, hey, this you can get the admin password by doing this, because that repository is probably being used by millions of people, and a bad guy like me will look at the issue and be like, you saved me a lot of work, and that's not something you want. You want to make life harder for me. So these are the two things which you should be really be adding to your repositories and projects. Go through them. It's a simple document and it's not extremely complicated. You can just write that, hey, if you find a vulnerability, email to this address with a POC. Even that's a good security.md. Then you decide that, hey, is this something which affects my users or not? Now coming to the interesting part, I should say, that, hey, how do I make money on this, right? It's a funny thing, because whenever you contribute to open source, you barely get any money unless you're doing under a program like GSOC or one of those things. But here, if you are good with security research, or like if you are just passionate about it, you can make money off open source contributions as well. And that's how I got through some of my college fees. So yeah, coming straight to the point. There's a platform called hunter.com. I really suggest this to everyone. I've been following these people since they were extremely small company, and they're amazing. They're amazing. They're extremely helpful. And what Hunter does right now, they're more inclined towards finding vulnerabilities to in AI ML software. We'll be touching on that later. But essentially, if you find a vulnerability on a platform, on a very big open source repository, and you're willing to disclose it, you can just report it via Hunter. And if it's in their program, or if it is a big enough repository, you get paid for it. They pay you depending upon the vulnerability, upon the repository. So there's plenty of fish in the sea. Let me just go to Hunter's website here. So you see there are plus 250 plus AIML repositories in scope. And I'll touch upon this later, why AIML repositories are such a gold mine, and it's essentially a hack. So let me go to the bounties section. So you see these are all repos which you can just go ahead and explore, automate. Most of them are ML frameworks, but you'll also find C++ stuff. I don't know why anybody would touch C++, but you have it there. There's Python. I'm pretty sure that somebody somewhere has JS repositories as well. But yeah, and that's the funny part. For a vulnerability to exist in an ML repository, it doesn't need to be related to ML, right? Obviously, if you know machine learning, because I don't, you can get that leverage there. But you can have programming language specific vulnerabilities or business use case vulnerabilities and things like that. So just for example, you can see that if you find a vulnerability in PyTorch, you can get paid upwards of $1,500, which is like what, 1,20,000, if I'm not too terrible with maths. There's TensorFlow, there is Llama. Just go to one of these and find one bug, and you're set for like at least 1.5 semesters. So yeah, coming to the next point. Now the question is, why should you care? We talked about CVs, right? So why should you care about it? These are just funny numbers on a funny forum. So if you're a security researcher, and if you're in your third year or in your fourth year, you will know that breaking into security is a pita. It's a big pain. It's a nightmare. I'll give you that. Security is one of the most difficult careers to break into. And one of the entry barriers which security faces right now is certifications. Recruiters, for some reason, they want to see certifications on you. right? And security certifications are extremely expensive. Like the cheapest one goes for $250. And that's not even the worst part. The worst part is, let's say you have a certification exams usually, and if you do not clear that out, you have to pay $250 again in most cases to get it again. And the thing about certifications is also that some of them expire, so you have to keep getting them after, let's say, 2 years or 5 years. So it's not a cheap endeavor. So this is where I think CVs come in. At least they came in extremely helpful during my career, because I did not have that much money to spend on a bunch of certifications. For example, the most popular one is called OSCP, and that costs around what 1.8 lakhs. And as a student, that's a lot of money. Even as an adult, that's a lot of money, right? So it's very difficult to get those certifications early on. So you can replace those lack of certifications in your resume with CVs. For any security researcher, CVs are a badge of honor. They are like, hey, I found this 0 day, and that's cool. That you go to someone and say that, hey, I have a bunch of CVs to my name, they would respect you. And CV hunting, as you'll see in open source repositories, they are extremely easy. They're a hack. I'll tell you, they're a hack. You're cheating your way through, but the job market is difficult, and you've got to do anything to get by. And again, as the third point elaborates, this vulnerability detection process that can be automated to a lot of extent. Like you can just have some scanners, or you don't even need to run your own scanners. You can just get some tools. Again, I'll discuss this later in the talk. You can automate the whole bunch and just sit down with your legs up and wait for the results, I guess. Like I said, it's an amazing substitute for certification. So if there's any aspiring hacker in the chat, I would really suggest you guys start going after this. Again, now this is another point which I feel needs to be touched upon, and that is hack the word. I have seen a lot of newcomers try to, find something extremely niche, critical, which is like I've seen people looking for extremely difficult things when they don't really need to do that. You don't need to find a 0 day in a very 100K start repository, which allows you to do something extremely critical, take over a database, dump the entire company's credentials. No, you don't need to do that. You just take a step back, start somewhere small, right? Uh, the two most hyped around vulnerabilities in this space are RCE and XSS. Um, RC is for machines, XSS for web guys. If you are a web guy and you think, okay, what will I do with an XSS? Study about XSS. This is something all web guys should know about, right? So these are usually the top tier of vulnerabilities which in their respective fields, and the lowest one is denial of service. But let me tell you something. In certain contexts, denial of service can be a bigger severity than RC. I mean, that's debatable, but I'm just saying, because I'll give you an example. There's something called a CIA triad: confidentiality, integrity, availability. Every system serves one of these three purposes and has a score according to it. For example, my router, even though it's like handling critical data, I need it to be more available than confidential, right? It's not like has critical data on it. It's transmitting critical data, but you can just encrypt it, right? But it needs to be available for all the times, because otherwise nobody will be able to access these machines. So if I'm able to perform a DOS on my router, that's more harmful to a business than a potential RC which doesn't like go or do anything like super scrupulous or use that to leverage to other machines. So that's the idea, that even something as simple as a DOS can be extremely efficient, or can apply for a CV, or can be pretty damning. So try to start small. And another thing is you can chain multiple vulnerabilities, right? So let's say you find one small thing, you find another small thing, you put them together to create a medium-sized thing. A very good example of this will be, let's say you find let me think of an example. Let me say you find a memory corruption vulnerability where you can override certain bytes of memory, right? and you find something called a ROP, where you can write jump instruction and jump to another places where you control the RIP and that stuff. Usually they go hand in hand, but if you are able to just do the right thing, you can overwrite memory in such a way that the return pointer gets overwritten, the RIP gets overwritten, you can control execution in the program. So that was a very bad example. That was a bad example, but you get the idea that you can use two little vulnerabilities to create a big one. So look for those. You don't need to report the small ones if you don't feel like they are gonna lead somewhere. Just keep looking and maybe find two or three things which work really well together. Coming back now, biggest question I get: where do I start? So go to Hunter again. Oops. Go to Hunter, and they have this community tab where they have blogs and reports and a beginner's guide. Right, just go to any of these blogs. I'll show you my blog. Where do they still have it public? Yeah. So go to this blog, see where the vulnerable statement is. Let's say this was the vulnerable statement. They were using a eval statement, and those of you who are familiar with Python, you know what eval does, right? So pick up these blogs, read what's the vulnerability. Next thing you want to do is use vulnerability detection tools. For example, on Python, there's this tool called Bandit. Bandit essentially finds insecure code segments in your Python libraries. Put Bandit to work. There's another platform called SYNK, Synax Sync. There's a bit debate on how you pronounce it, but the platform is SYNK. And what they do is they do the same thing. They scan a repository for vulnerabilities. You can just add as an hook to your GitHub actions as well, which triggers every time code has been pushed, and they go like, hey, we scan this code base for you, this commit for you, and these are the potential vulnerable spaces where we think that attacker can attack. Right. So you find an existing code base, you find critical codes, you go to Synac, you use Bandit to evaluate current code. And I think the easiest place to start is just go through your own project. All of us have done security project, not security projects, general projects during our college. Just run these tools or whatever is the respective tool for your own language. Just run these through your own projects and see where are the vulnerabilities, what are the things coming up, what did I do wrong, can I attack it, can I abuse it, right? And that will give you insight about what are the common developer mistakes. And once you've found one of these critical things, go ahead, try to exploit it, get creative with it. And if you're able to successfully exploit it, um, you have got the practice. That's your first open source repository, which you found an exploit in. So coming back, getting lazy with it. So this is a very controversial part of the talk where I'll tell you how you can quote unquote cheat the system, and how do you like kind of automate this whole thing. So I'll give you an example. I'll go to my repository, and this was a vulnerable code snippet, right? Yeah, what this whole thing was doing, I have a latest slide as well, where it is taking insecure user input and evaluating it, which is allowing us to give uh, inject commands in a way. Right, you find a vulnerable snippet. Once you have that vulnerable snippet, you use open. Let me go back to the slide. So there are three tools. One is Search Graph, another one is GitHub, another one is the usual grep tool. So you take a combination of these three tools and you search for similar code vulnerabilities. So let's say you come here, source graph. I say, hey, show me where is eval. I'm not gonna write regex. I'm not gonna embarrass myself in front of everybody. And so I'm just searching for the normal eval function, right? And they gave me 10,000 results. Oh, okay. Let me just put. Oh, this. You can for search graph alternatives. You can also go to source graph. I use source graph because they let you specify a lot of things. For example, I want to search this in Python. If I do that, see there are a bunch of. This is a bad one. I'm looking for. No, these are all classes. Let me find something. Oh, I'm not sure if model.eval does the same thing, but you get the idea. You can get all these statements. So what I did was, for my particular uh, mm, vulnerability, I searched for eval.get env. I'm hoping something will pop up. Yeah, it's ast.literal eval, which is a secure version of eval. But moving down, anything. So see, here it is. Paddle, a very popular GitHub repository with 21.9K stars. What they're doing is they're evaluating the shape parameter, the shape environment variable directly into a eval statement. So this is insecure. If you are able to control environment variables, you can explore run code within the context of whatever this program is. Right. So here is the first open source vulnerability right here. How long did it take? So similarly, use the same approach. Pick up vulnerable snippets from existing repos. Use a combination of grep, GitHub, and source graph or search graph or any other similar code searching tool and find these vulnerabilities, right? But that's not it. That's not it. Just because it has a vulnerable snippet, that doesn't mean that you can just go ahead and randomly report. There's a certain discipline to it. First of all, you definitely need to check the security.md to see what are the rules set in place, talk to the developers and see that, hey, do they consider this a vulnerability? And the third thing is try to exploit this. You can have somewhere some vulnerable code embedded within vulnerable code embedded within secure code. There can be a lot of hoops to jump through. And some of the vulnerable codes might be in examples or test repositories which you don't want to touch because they usually don't run on a lot of systems. They're just there for tests and examples for people to refer to, right? But things like these, if you see that there is a critical flaw which can be exploited, go ahead. I encourage reporting it. And finally, start small. Start small. Chain vulnerabilities. Okay, so we found an os.eval environment injection. What else can we do? We can live in the context of the program. What else can we do? We can get rc from it. What else can we do? So okay, I found another vulnerability which lets me write to a file. Okay, what can we do with this? We can overwrite, let's say, password files in Linux and then get access to it. So chain these things together, you can get something as big as a host compromise, right? So finally, I would like to talk about how I found a very funny secure vulnerability in PyTorch Lightning. I'm not an ML guy. I have no idea. I remember learning about regression learning, and I forgot the other two. There were three definitions they made us read in college. I've forgotten every bit of that. But my biggest like find was in PyTorch Lightning, which is a big repository. Right. So me and my college friends, the boys, we were working on, like, they were working on this ML magic project, and I was just there for moral support and getting some documentations done. And we needed some GPUs, which we were getting from this vendor. I cannot disclose their name because otherwise, uh, that's the crux of the profession. And there was one place where we needed to control the number of GPUs going into the model. I left that part to the ML guys. But I was quite interested that, hey, what happens if I tamper with this? Because as a security guy, you are or it's like being an autistic guy with who wants to tinker with everything. And I put something called Bob Suit there. I was like, let me tinker with this number. I'm dedicating 16 GPU cores to this. What's actually happening? Right. And during that test, we were using PyTorch Lightning. I decided to go look at the repository, and then that's where I found that they were reading the number of GPU cores using this combination of eval. If you go to this report somewhere here, pretty sure they were reading. Yeah, they were using this particular environment variable PL trainer GPUs to read the number of GPUs or something. Not sure how that works. Left it to the ML guys. But I found out that by controlling the input to the vendor integer value, uh, we could backdoor the entire GPU system, right? So that's exactly what we did. I put in the repository there, and then the GPU vendor came back to me and said that, hey, this is not a problem on my end. This is a problem on the repository's end. It's part of the code repository. And then I went to the PyTorch guys, and they were like, you know what? This is something critical, and we should be fixing it right now. And they did that, and I got this report done. I think I pushed a bounty as well, and they gave me $75, which was good money. Good money. Got some GPA splits cleared. Oh, I forgot to mention this. Not only do you get paid for over Hunter, not only do you get paid for finding vulnerabilities. Let's say you found something, you also get paid if you make a commit to it, or whoever makes a commit to it and fixes that, they also get paid for that same thing. So it's a win for developers as well as for the hackers as well. So it incentivizes like secure open source, and I absolutely love these guys for that. Not a lot of people are working in this space. So yeah, the point wasn't that it's $75. It's that somebody who has no idea of machine learning or anything ML was able to find a critical vulnerability in a big open source repository. And you and I'm pretty sure other people have looked at it, and there's always a luck factor, there's always a relentless factor, but this is where the funny thing started. As soon as I found this particular environment variable trick, I use the same thing from the last slides, or getting lazy with it. And there were tons of other repositories which followed the same pattern. And I was able to replicate that for them as well. So it was like a money glitch. And this is why I was saying that it's a good thing that machine learning repositories are so favored by Hunter, because if you will take a look at machine learning repositories, you'll see that a lot of the code is not written with the best security principles in mind. So what you do is you can go out and reach out to and they're vastly used. So you can reach out to people and say that, hey, I found these vulnerabilities. Some good ones to look at as temporary file reads writes. There's a lot of unsecured pickled data stored. So I've seen people saving pickle data to a temporary directory with 777 permissions. So if you're a low privileged user, write to that pickled file and get shell as a privileged user as well. So just some tricks out there. So if you see a machine learning repository, and even if you are not a machine learning guy, it doesn't hurt. It doesn't absolutely hurt to take a look. So yeah, that's pretty much the story which I have. Let me see chat. I don't see much. Hi everyone. Can they pay me for making vulnerability? See, that's a hack. If your repository is extremely popular, let's say 25K stars on GitHub, and you put some vulnerabilities in there, do a secret handshake with your security friend that, hey, I report this, you fix this or something like that. Maybe, maybe, but that's not right, because that takes away the incentive from real creators who are actually working in. So please don't do that. Should I switch to Linux for better learning curve? Dude, I have I use Arch t-shirt and I use Windows. All right, so there's a whole, yeah, definitely use Linux for 3 years, 4 years, do everything on it, lose your mind, try every top 20 distros on DistroWatch, do it, and then come back to Windows. Because your work, like for me, if I wasn't in security, I would probably be using Linux, but I also game, and I work with Windows APIs all the time, so I have to use Windows. But I absolutely suggest learning Linux, because it teaches you how to suffer and actually enjoy that suffering. It's like Dark Souls, but uh, operating systems. So yeah, ESB, definitely try out something with Ubuntu. Start with Ubuntu, move to CentOS or Tumbleweed, something like that. No, sorry, CentOS got discontinued. I'm still living in 2019. Um, Start with Ubuntu, move to Tumbleweed, Fedora, and then come to Arch, and then probably Gentoo and Linux from scratch. That's the journey. Um, DBC, I find a vulnerability and make fix to test it because I don't want to do crowds. Okay, you don't want to do CrowdStrike 2.0. You find a vulnerability and make a fix to test if it was good. Yeah, that's why we have branches and like testing tests written all throughout, like write test driven code or something like that. But yeah, CrowdStrike was an unfortunate incident, but they had to do it. When you're such a global. I'm struggling with CrowdStrike once. They are amazing with their firewalls and MD EDR solutions, and even after this call, I have to go fight with CrowdStrike on security business. But so that's a conversation for a different topic. Make local tests. That's what I'll say. Before pushing to production, test things locally. Folks, can you shoot your questions? Can you please tell us more about the CrowdStrike stuff? CrowdStrike is okay. CrowdStrike is an EDR vendor. EDR vendors are like antivirus on steroids, right? And for a lot of things to work on an EDR for detections, EDR basically detects malicious payloads. They need access to the kernel objects, right? They need to be present in the kernel because to catch callbacks, look at the memory because the kernel has no restrictions and some other stuff. So they need to write drivers for it. I know that's the thing about kernel drivers. In a Windows, if you write a user land application, something goes wrong, the application crashes. When you go to the kernel, you write some wrong applications, the entire operating system goes down. So there was this one particular edge case where there was this operation which was trying to reference an invalid memory address, and that crashed the whole system. That's it. That's the whole CrowdStrike incident which happened last Friday. And that's it. I don't see any questions. Uh, Let me scroll back up. Hacker, hey bhai, hacker. Unfortunately, yes. RJ, can't wait when it will start. Join our Telegram channel. Uh, Nijika, you can be me for making. All right, I don't see any vulnerability. Sorry, I'm speaking security. I don't see any questions in chat. So, anyone else, or we can just end the session. Feel free to reach out to me if you guys get stuck. I'm really hoping to find some good security people. And yeah, that should do it. Let me stop sharing my screen. Hi, Bhaskar.
Yeah. So what would you what would you like advise someone who's been who has no experience in security? Yeah, right. Like someone like me. Like I've had this question for a while now. Like I've found finding vulnerability is cool. Yeah, I wanted to do it, but let's say I want to find a vulnerability in a new repo, in a repository. You I open it, I play around with it, and I find nothing. Find nothing. Yeah,
All right, you
because
then don't find anything. You move on to the next repository. You won't find anything. That's why if you go back up, and here's the thing. Where is it? Where do I start? Start by scanning your own repositories. First go through the code yourself. This is what we call secure code, where we go through a piece of code and see, hey, can there be loopholes? For example, let me see. Can I give you guys some example? I'll give you a very funny example of a insecure code which I came across in my career. As soon as this thing starts, my operating system starts listening to me. Hate you, Mac. Anyways, so go through your own code and see if you can find something. And if you're not able to find something in the first try, go to something like, let's say, Synac. They will definitely find something for you. And that way you learn what secure code versus what vulnerable code looks like. And then you start looking for it elsewhere because you're not the only developer who's making that mistake. Not only that, sometimes the vulnerabilities exist within your dependencies as well, right? And you can just scan those dependencies. We have depend-about alerts, right, on GitHub.
yeah,
Just correlate those to vulnerabilities and security repositories because your code might not be vulnerable. What the components which your code uses, they might be. A very good example of this is PyYAML repository. Uh, they had a vulnerability in PyYAML 1.6, if I'm not wrong, which related to deserialization. So they fixed it. They pushed it out, case closed. A lot of repositories, they did not update their requirements.txt. They did not, right? So every time they were parsing a YAML as a part of one of their processes, it made them vulnerable instead. So if you are unable to find something in your code, look for the dependencies. You will use the online tools, use Synac. And if you find Synac will definitely give you something, right? And once you find those pain points, Just look for them in other people's code using source graph, or just Google on Git, just dot Git. Even that works. I used to just do a grep minus I capital R a piece of code, and it worked out somehow. Right. Go to GitHub, get create a text file with all 100 repositories every day, top 100 repositories, git clone them, find code, find vulnerable codes, and just pipe it out to a file and go through it. It's that simple. Because yeah, you won't find it, let's say in day one, day two, day three, you will find something. Talk to the developers and make them understand that, hey, this is what's going wrong, this is how we can exploit it, and you have yourself a CVE.
I think I'll definitely try looking for some.
Yeah, and cheat. I'll be very honest with you. This is not something I'll say in any other context, but definitely do cheat. I believe tech is based upon cheating. You copy each other's work. See what
Did
are
you
the
mention some
vulnerabilities that are
automated tools
common.
on Monthly?
Yeah.
You mentioned some automated tools. Can you go over them once?
So let me show you guys. I usually use Python, so I know the tools for Python and some general stuff. Juby. Okay, so there is this website called Synac. So they do automated scannings for you. This website, you can just give it a GitHub public repositories URL, and it will do the checks for you. This is one. So you see there are these options: start with Google, start with GitHub. That's one. And another tool which I use for, let's say, Python is Bandit Python audit. See, Bandit is a tool to security issues in Python code. So every language has their specific set of tools. In my experience, Synac is a general thing which applies to every language, whereas Bandit is for Python. So because most of the machine learning repositories out there, they are coded in Python. So these are the two places which I'll definitely look for. And yeah, that's about a good place to start according to me. Just use these tools, and once you find go to Hunter, read the reports, just look for the vulnerable snippets. That's it. Just look for the one. Use grep. Just use grep, man. That's the thing. It is so stupid that anybody can do. I could do it. Anybody could do it.
Thank you so much for joining us today. Yeah,
Yeah,
really
sure.
loved. Yeah,
I
like
love coming back and to our IIIT events. Hopefully, I'll get some questions after this.
if anyone has any more questions, feel free to connect with Debjeet. And yeah, we already talked about that. So make sure to subscribe and hit the bell icon. Yeah, and we'll be wrapping up here today. Thank you for joining.
See ya, guys.